All right, welcome back. Let's try this video again. We're on attempt number 4 because my computer keeps corrupting the videos as soon as I finish them. So here's hoping this one works for you guys today. Anyways, so here we are. We're back in our project, same as we left off in our last video. Nothing really changed. And as I mentioned at the end of that video, we need to talk about now how do we persist data between uses in the application. And there's several different ways we can approach that. For example, we already talked about how we could use, or I mentioned at the end of it, we can use saved instance states and we can bundle those things together. And that makes sense that for data that you want to persist between simple things, maybe like a rotation or your application coming out of focus for a while and the user returning to it either via the backstack or the recent apps button. But otherwise, what happens if you want data to persist between complete cold launches of your application? Not just minor things like that. And in those cases, we have a few different options. Option number one is we can use a database. And we'll cover that later in the semester using SQLite. We're going to use an abstraction layer that will simplify our lives pretty substantially. But you should be pretty familiar by this point in your CS career with databases and how they function. So that's an option, but for simple things, a database is just too much overhead. It's too much work. There's a lot of moving pieces that are completely unnecessary. A lot of extra space that's taken. So what if we want to store just a couple of simple things? Well, there's one option we can use for those. It's called a shared preference. Now, shared preferences are persisted to disk. I guess the best way to describe it's kind of like a dictionary, maybe a hash map. You provide key value pairs to primitive data types you want to store. That's one of the limitations. You're limited to some basic data types, booleans, integers, floats, strings, string sets, some just basic things like that. There's not a whole lot we can put into it since it's limited to those key value pairs. But it's really lightweight, it's pretty quick. So when you've only got a couple of things you want to store, that's great. Should be aware of limitations on it though. We can't store complex data. You don't want to store large volumes of data on it. Performance goes down pretty substantially when you start to get large volumes of data in there. But if you only want to store one or two things, or a handful of things, or maybe even a few dozen things, you're probably okay. But as you start to get to a lot of things, you really should start to look at a database and the flexibility and the power that comes with the database. So shared preferences are ideal when we want to do just simple things, which is what we want to do with our application. As we've got our application up here, really what I want to do is I want it to be able to remember where the seek bar was and have the application come back to exactly where it was if I were to say quit the application and relaunch it. I want things to come back exactly where they were rather than starting from scratch. And in those cases, shared preference is a pretty decent solution. Really, it's only going to require us to save one value for that. So let's look at how we're going to do that. So we have our seek bar, and as we can see in our logcat too, if we put that filter back in place, our seek bar is changing a lot, right, as the user changes. So one option is we could put that in here into our on progress changed. However, as the user continues to move with this, that's actually going to cause a lot of unnecessary drain on resources. That's extra battery power, it's extra disk access, and we've got to be aware of those things when we're running on a limited resource device such as a cell phone. You wouldn't think big things like little things like that would make a big deal, but in the end they all start to combine. And if you're writing to disk dozens of times a second as the user is scrolling along, for example, you're going to really create poor performance for your application. So rather, you should take a little bit of time and plan out ahead of time. Where are you going to save data? What data are you going to save? And how are you going to get that data to where it needs to be? So one really good option to do that with is through the use of shared preference. And if we think about the life cycle of this, really, when is the only time we care now to save that particular pieces of data? We don't need to save it every time it's changed because the application's responding to that change as it's happening, which is good enough. really we only want that change to happen before the data is about to be lost, when it's about to be destroyed, either from a rotation or the user pausing the application or leaving the application. So in that case, we can use the on-pause lifecycle event. It's ideal for this. So let's go ahead and generate an on-pause handler. So now we're going to save it out to disk when we pause it, not when we're getting changes or consistent changes, just when we pause it. So shared preferences are pretty easy. First thing we need is a shared preferences object. And the way we get the shared preferences object, since we're in a fragment, we've got to get it from the parent activity who is responsible for holding it. So we can get preferences. We now need to provide a mode to it. We've got several different modes. The mode you're going to use almost all of the time is mode private, meaning keep my data alone. Nobody else can touch it. It belongs to me and to me alone. There are other modes, and you can look into those, but 99% of the time when you're writing a shared preference, mode private is the way you want to go. If you want to share data between multiple applications, for example, there's better ways to go about that are safer and more intelligent and easier to use. So we'll go ahead and set our mode to private. Now, that just simply gives us access to the shared preferences object. Shared preferences object has the ability to read data, but not to write data. When we want to write data, we need to use a class that is nested within shared preferences. Specifically, we need an editor. So getting an editor is pretty easy. Let's declare a variable to hold it, shared preferences dot editor. And let's call it spEdit. I like that name. And spEdit comes from the shared preferences object, and it's going to follow the factory pattern. So when we ask for spEdit, this will now create an editor for us to work with. And then the spEditor allows us to put different values. As I mentioned, you can put an int, a boolean, a float, a long, a string. You can see those. You can look up the other options you've got. You can see all of those, the details of that stuff online in the API. But we want to put, for example, an int. And as I mentioned before, we're going to take a key value pair. So we need to give it a key. Let's call this seek value. And then we need to give it, what is it that I'm wanting to write? Well, in this case, I want to write the progress, or the integer that represents the progress of my seek bar. Now, all this is going to do is queue this change to be put into the, to put to disk. All we're doing is queuing it up in a transaction. Nothing has been written yet. To write it out, we need to spEdit.commit. Now, commit is a blocking operation, okay, which means it is going to stop everything your application is doing, and it will put it out to disk right then. That's an immediate operation. There are times, though, when the timing of it's less critical and you really don't care, in which case apply will work just fine, because that will queue it up and let it run in the background when it makes sense to do it, rather than blocking the thread of your application. So apply works in a pretty good, a pretty substantial chunk of the time there, because that allows it to happen when it needs to happen. But sometimes you want it to happen immediately. Now, for the purposes of this demo, I want it to happen immediately, so I'm going to leave it at commit. But you can understand the two of them together. Okay. Now, this will take my values and put them now into my shared preferences. That does not, however, for example, if we run our application, oops, wrong button. We run our application, seek bar, rotate, we're still back to ground zero. Nothing's happened. All I'm doing is saving those values out. What I need to do is now use those values. So we've saved them here. Okay. Now saving value or restoring those. So on our resume, this makes a lot of sense here. Let's get our shared preferences. sp equals it activity.get preferences in mode private. Okay. And sp now, instead of put, we're going to say get int. And we want to give it the int with the key seek value. Now, it'll take two parameters here. First off is we need a key. The second is we need a default value. This will prevent us having null values. For example, the first time an application launches, there will be nothing for our shared preferences to return to us because we've never saved it out. So I'm going to just put 50 for now, because then it's easy to see it'll land in the middle of the bar. Okay, and this will return that to us. So let's call it int seek value. This will give us an integer. We need to now apply that integer to our seek bar. So seek bar dot set progress of our seek value. Okay, this will reach out to our shared preferences, return, give us an object. Then we can get an integer, and if that value is found now, if that key exists, it will return that value to seek value. If it does not exist, whatever I put here as my default value will be returned to me. That way we're guaranteed contractually that the data will exist, and we won't be passing a null and causing our application to crash. So let's go ahead and run this now. Okay. We start it up, and let's rotate. And now we're getting a crash. Let's look and see what's happening here. I left this crash here on purpose because this is a great opportunity for us to talk about some issues that you're going to be facing both on this assignment and in future applications. Okay. Remember, we're looking for the red here, and we're going to see we have an unable to resume activity, specifically because we have a null pointer exception. Okay, so something is null. Let's go down our thread now until we find something in blue. Okay, so our null is coming here on fragment amount on line 56. So easy job here. Let's set a breakpoint and see if we can determine what thing is coming back as null. Okay, here we are, we're running. So on this line, there's a few things involved. We've got our big decimals, we've got our rate that's coming in as we would expect, we've got our number format, but if you notice, there's one thing that is null, specifically our text amount. Now, text amount is populated on resume. So what we can tell from that, if we look at this, in fact, you'd be able to see it if we populated things a little bit differently, maybe some background colors or something. But our seek bar is in the process of being built. This first fragment is being built. This second fragment, in its life cycle events, has not yet fired on resume. So we have a timing issue. And this is a common issue we have to be aware of. We've got to plan out carefully how we will use and deal with data in those situations, especially when we get multiple fragments involved. Sorry. Forgot to reopen this after my computer crashed, or had to be restarted after this video attempt. So let's talk about what we need to do here. Okay, so we have a few different pieces coming on. Okay, we've got our fragments. Okay, we have the seek fragment, we have the amount fragment, and we have the main activity, right? Okay, seek communicated an update to the progress to the activity, who then tried to send that off to amount, which has worked great in all of the other cases. But amount doesn't actually exist yet. So we're going to do, this is what we would typically call a push, right? Because this data is being pushed to the other piece. What we need to do to enable, though, instead is, well, when amount is ready, then let's let it go ahead and pull the data. Now, it will only need to pull at the beginning. We want the pushes to continue to function. So we need to stop the application from exploding. That's pretty easy to do. We simply need to make sure the thing exists before I try to use it. So we can say if my text amount is not null, then go ahead and set the text. If it is null, well, that's not going to do us any good. Excuse me. So this will block it, and it won't crash anymore if we run it again. But again, if I rotate, I'm not crashing anymore, and my seek bar is staying where I want it to. But you'll notice the amount, as soon as the rotate and it's rebuilt, my amount is being erased, which is problematic. Now, I could choose to save the amount in the fragment amount, but that's really, best practice isn't to store a whole ton of values there, especially when something is meant to be calculated. Rather, we can store the one value we need to calculate it, and then just use the calculations, run the process as we expect to. It's easier to solve the timing problem than it is to try to keep a whole bunch of things in sync. It's really going to be error prone for you in the long run to try to do something like that. So let's just solve the communication issue and the timing issue. So if I want this guy to be able to pull data, okay, if it's going to pull data, that means it needs to be able to reach out to activity, who would then reach out to the appropriate place. Because as far as amount knows, it only exists between it and the activity. It's completely unaware of this other fragment, but the activity is the orchestrator, knows what needs to happen. So as you'll remember, the way we make those communications take place is now we need an interface. Let's call it getData, just for simplicity. That requires a single method that will return an integer. Let's call it getTaxRate, because we have our update tax rate that's called. And we'll want now a private variable to hold our getData callback. Okay, we now need to attach, just like we've done now with several assignments and in several videos. Let's override on attach. Again, choosing the deprecated version with activity. Okay, we want to on attach. So let's try to cast that. So does m callback cast to get data? Does it implement my interface? If not, we want to catch a class cast exception, E, and then just like before, let's throw out a new one. New class cast exception, and let's say activity dot toString must implement the getData interface. Okay, same thing as we've done before. We're attaching, and we're going to make sure that these things work together. Okay, that I can call my method. So that means in my main activity here now, we need to implement another one. Let's call it fragmentAmount.getData. I'm going to tab it over because I'm OCD. I like them to line up. Okay, and Alt-Enter to implement the stubs of our method. We're required to implement our tax rate. So by default, that tax rate is going to be 0. Now, we have options again here. Now, one option that a lot of students will want to default to is, well, let's just have main activity store a copy of the integer. Okay? But that solution does not scale well to larger applications. When we start to get a lot of data moving back and forth between these pieces, it doesn't scale well. Rather, main activity's job is to orchestrate, not to store. Its job is to orchestrate communications. So fragment amount says, hey, I need the tax rate. Okay, cool. The activity is going to say, well, where do I get that tax rate? In this case, that tax rate is the responsibility of our fragment seek. So it's going to need to reach out to our seek method, or our seek fragment here, and get that tax rate. Okay, so let's make a method that it can call. Let's call this public int get tax. Well, we could even call it seek rate, or if you want to call it tax rate. Okay. And this one now is just going to return our seek bar dot get progress. Okay, this will give us an integer of our progress, the same as what we were getting here on our on progress changed. I could store that value again, but why waste the memory? When seek bar is responsible for tracking it already, I can just ask seek bar for it. However, we need to be careful here again for timing issues. Okay, what if frag amount is being constructed before seek amount is done, which is possible. You know, if you remember from CS3100, there's timing things, especially with multiple threads going on, can be a little unpredictable sometimes. And transactions like this that are happening asynchronously, in the case of the fragment manager, are like that. Depends on how things get handled in the thread pool. So we need to then put some safety checks here. So let's get ourselves, first off, we need a variable to hold our fragment amount. Okay, in this case, though, let's call it fragment seek, because that's the piece we want, fragment seek, just like we had before. And we're going to populate it the same way we populated this one. So fragment seek is going to be fragment seek, and we're going to get that from our fragment manager, and we are going to find fragment by tag, looking for frag seek, because that's what we called it up here when we process the transaction. So give me frag seek. If fragment seek exists, i.e. it is not null, then go ahead and return the method. So we'll call fragment seek dot get tax rate. Okay. Otherwise, return some default value that makes sense to you. So I keep a 0. You know, we can put braces here. Maybe we should do that so we don't be lazy. Okay. And in reality, we should probably do the same safety check here. So if fragment amount is not equal to null, then update the tax rate. If it's available, let's use it. Okay, null checks like that can be a smart thing. So now, my tax rate, okay, let's run this again. Okay, my seek bar is repopulating, but notice my amount, let's rotate it so you can see it again. My amount is still blank. Now, what could be going wrong here? Now, I want you to pause the video for just a minute and see if you can debug this and see why it's not working yet. Okay. Now, hopefully you've taken a minute, you've thought that one through for just a second, because what do you think's happening here? Well, our tax rate's working, but if we were to set a breakpoint here, for example, we're going to notice this method is never actually being called. In fragment mount, all we did was here in our update tax rate say, well, if I could set it, set it. But if I haven't, if I'm not, then don't. Well, we're never, in our on resume, we're never asking for it to be set. So we need to call our own update tax rate this time so that the data itself is being pulled. Now, one thing to be careful with here, okay? Some students get a little confused, so we're gonna talk about this line of code a little bit. We're gonna call this method. Now, rather than re-implementing all of this logic here, we're better to just call the method that knows how to do that work. That's kind of the point of methods in the first place. But the thing is now is, where is this rate coming from? Because before it's always been main activity that gave us the value that it already had because it was being pushed by fragment seek. Rather, we want this guy to pull the data. So where can this fragment pull the data from? Well, that's what we just made that M callback for, to give us the tax rate. So what's happening is it's going to first reach out order of operations to M callback and get the tax rate, which in main activity, really what that means is using our fragment seek, go and get that value from fragment seek, right? Essentially from our seek bar, and return it to the activity, who then returns it now back to fragment amount. Okay? Another way we could write this is the same thing as if I said int rate equals get tax rate, and I just passed rate in. Okay, it's the same thing. The only difference is this is going to use a little bit more memory because I am going to store it as through the duration of the method, versus anonymously it would only exist for that for that single line. So a little bit more memory, but not a big deal. Either way, whichever one makes more sense to you. Okay, but I want you to think about what's happening here now. So now let's run our application again and watch what happens. Notice now our seek bar is restoring, but also so is our amount. So we rotate, and everything is the same in place. Right? We have our seek bar, it scrolls, our amounts are stored, because what's happening now is amount is finishing its instantiation, and it's reaching out to the activity saying, hey, give me that value that I need. I'm ready for it now. Activity that says, okay, let me go get it from seek, who has it, and send it back to you. And then as we're scrolling in the future, because both of them are ready for data, C can go, here you go, activity, I've got data. Activity says, oh sweet, amount needs that, and forwards it over to amount, who then processes the data as needed. Okay? There's a lot of moving pieces there, and we want to be careful with those. Okay? Now, a couple of other things I want to talk about. Let's see if we can get those done quickly here in this video. What about, I mean, if you're noticing, is this thing's rotating here, it's kind of ugly. You got still got the seek bar up here and the amount down here. And, I mean, what if we wanted to make this look a little bit better? Well, as I mentioned in the video in the last video, we've got our layout here, but I could also now add a new directory here. Let's make a layout -land. Okay. Now notice I made that, but nothing showed up. Okay, that's because we're in Android view. If we switch to project view, the IDE won't attempt to hide that from us. Okay, so that we can now have our layout, except it nested it out. Let's bring it up a layer. There we go. So now we have layout land. So if I wanted, for example, to take my main activity, I could copy this guy into place, into this layout landscape, and now the IDE will automatically pick, when I'm in landscape mode, what do I want to do differently? In this case, let's let them sit side by side. Let's consume half the screen side by side now. Okay? And instead of having the height be 0 dp, let's invert these. Oops. 0 dp, and let's put match parent now for our height, meaning take all of the height that's available but split the horizontal space. Okay, so Android will automatically target the appropriate layouts for us by us telling us, well, this one is layout specifically to landscape. If we don't have one for landscape, it will default to what exists here. So now if I rotate my screen, notice my seek bar takes half the screen here, side by side. Just like I showed you with that calculator, we got different layouts for different screen spaces. Just like you would expect, you want things to be intelligent. Your users expect that, so you have to spend a little bit of time. As easy it is to let Android just recalculate things with now a bigger width and a smaller height when it's on its side. You know, if you've got something you can do with that real estate, by all means, take advantage of those situations. It's not hard. To allow you to do this. And you can do the same thing with fragments. It doesn't have to be just the activity. We could have our fragments could lay out completely differently. The one thing we do need to be careful about, though, is it can get a little tricky if you add things and remove things in one layout versus the other. And if you do that, then you simply need to check to see which orientation you're inside your fragment or activity, and then handle your logic appropriately. Just be a little bit careful with that, so that you don't end up hurting yourself in the long run. I'm going to go back to Android to app view here. Okay, so notice activity main shows up as 2 because I have main and now I have a landscape version. So when you're in project view, you can see both of those. Okay, the last thing you're going to need to do for your particular homework assignment this week is we need to allow the users to input text. We want them to be able to edit text. So in this, let's go, in fact, let's add one in here into our fragment seek. Let's allow the user to type some stuff in. Okay. Now, at the simplest version is just a straight up edit text, which is simple in BASIC. You know, you've seen those, but it doesn't provide things for hints or telling the user what's going on. Rather, there's some more intelligent versions that we can choose to use if we want to use, the material design provides. Really, it's up to you what you want to use, depending on your layout and what it is you're looking for in your application. I'm going to use the text input layout just because I like the way that it looks and all the intelligence that it adds to it. Now you'll notice when you drag that one over, you're going to get a message saying, here, we need to add a project dependency to Gradle. It needs the library design. By default, we can push OK, and it'll go ahead and add that for us. What that's doing, if we come back over to our Gradle now, oops, sorry, wrong one. We want the app. In our dependencies, it added a new one, a new implementation for com.android.support.design for the design tag, specifically version 27.1.1. This tells Gradle, if you've ever done like with, say, PHP with Composer, or you've dealt with, Maven or some of those other automated build tools, Gradle's like that. It's what we know as a dependency manager. In fact, you may have used some, they exist for, like even HTML and JavaScript packages, or if you've ever dealt with Linux, we want to automate those things so you don't have to try to download and manage versions and all those other things. Let Gradle do it for us. So it's something can be easily abstracted away. So you usually say, I need to use something, and let the tools go do it. This is the line that it added when you pushed yes. If you said no, you would have had to have come in and added it on your own instead. Now, when we drop it out, you'll see this actually exists of a few things. First, we need a text input layout, which is a parent widget, and then it works with a text input edit text. We'll show you how this guy works in just a minute, but we need to give an ID to it so we can find it. Oops, not an if, an ID. Let's see, amount. Okay, let's call this guy amount because that's what we're going to have the user type in rather than using our hard-coded Burrito's dinner value or Beto's burrito value. Let's let the user type in how much money they spend to calculate things from. But just so you can see how this works, let me go ahead and input it, or go ahead and run this real quick so you can see what the edit text looks like. Give it a second here to build. The first build after you download a library is going to take a few minutes because it's got to reach out to the internet and download a whole bunch of stuff first. So now when it's in focus, whatever you put there, I put hint right here, is going to be in place, or if I click into something else, if the user, if it wasn't trying to type right here, that hint actually moves down into here. You'll see once you start to layer multiples of them together how it functions. So we should replace that word hint with amount spent. Okay, and again, let's extract that string resource. So we don't want hard-coded strings, but now the user can type things in. However, we're wanting them to type in an amount, so it doesn't make sense to have my default keyboard be letters. We can change this pretty easily as well by setting the input type to a number. Specifically, we want to do a decimal. That will change our default keyboard so that by default it's going to come up with numbers, because that's what we're expecting to receive. When we click into the field, now I can say I spent $12.47. Okay. The thing that we want to have happen now, though, in the long run, is we want this to affect this. So rather than right now, amount is using, if we go back to fragment amount as part of its calculation, it's using a hard-coded value. We want that value to come from this fragment now. So there's a couple of ways for us to do this. Easiest way is we're going to use what's called a text watcher. Okay, so we're going to need first off access to that edit text. No, not edit text, text edit. Okay. EDT. I'm going to call mine EDT amount. Okay, for edit amount. Okay, and in our on resume, let's get it. root.find view by ID r.id.amount is what we called it. Okay, there we go. So this will give us our text editor. Now we need to write a text watcher to go with this guy. Now text watchers are a simple class that we will then attach to this guy. So we can go ahead and make a text watcher. Amount watcher equals new text watcher. Okay. Now, if we wanted to run this anonymously instead of having it stored as a variable, that's totally an option as well. Because what we're going to do is after we have this, we're going to take our EDT amount dot set text. No, that's not it. Oh yeah, I remember. This is a weird one. It's one of the weird things with Android. A lot of the listeners are set when you're trying to attach them to things. This one's an add. Particularly is a little annoying. But we want to add a text changed listener, and we'll pass it our watcher, amount watcher. So if you wanted to go anonymously like we've done before, we totally could do that and go as an anonymous class. But when you're going to have the reason I did it this way is because later on in your assignment, you're going to need multiple text fields working together, in which case you don't need a watcher for each one. You can use the same watcher for all of them because we're going to be doing the same thing. So really what we care about is what do we want to have happen when the text changes. So if the text view, once the text view values have changed, really we want to now push a message out again saying this text value has changed or something else like that. And in fact, it may be even good to have it all packaged together and have using a POJO, a plain old Java object, put together our seek value and our seek rate and all of the amounts, because in your assignment you'll be having to add up multiple amounts and you're not going to want to ship those multiple times. So whatever you want to have happen here will happen inside of our text change. So I'm going to put a log.d for purposes of the video. Text, let's see, text changed to, and let's put a copy of it. Now you'll notice when I do on text change, this is going to give me the character sequence, where the change started, what before, and the count of things that are changing. You can do really fancy stuff with this, but in reality you don't need to. We want to just simply see what's happening here as the user's typing out, because that's what you're going to care about is the total amount. You're not going to be doing anything fancy for this particular point in time. So if the user types in and they spent 12, you're going to notice in our logcat we got a 1 and then we got 12, 3.478. Well, we can't have 8 because you can't spend that in money, but you get the idea, right? And we could put some restrictions on this edit text so that it can only type in things that conform to a money format, with 2 decimal places and all those other things. I don't want to get into that for this assignment. I feel like we've got enough new things going on already. I don't want to overwhelm you. So let's leave that here for now. I'm not going to show you how to add that last piece of communication here because we've already done it. With the rates, I want to see you put all of these pieces together now, that you see how we monitor when text is changed, how do we handle all those other pieces. The last thing I need to show you is how do we handle scrolling. Maybe we want, for example, if we're going to have a whole bunch of lines inside a fragment seek, maybe I want to put more than fits in this screen. For example, what if I were to come in here, I'm going to just draw up in a pile of them. Whoa, why are those all nesting? That's weird. drop it down here. No. So you can see where the design editor gets a little annoying. So we're going to just come in here and Control X it and put it where we want it. Let's put a handful of them. You'll notice when we get in here, we now have a whole bunch of these guys in place. Why aren't the other ones rendering? Did I break something when I was undoing? I probably broke something. What did I break? Oh, I see what I did. That's kind of silly. Actually, I'm glad I did it, though, because you guys will run into this problem later on. If you notice, in our text input layout for our height, it is set to wrap, or to match parent. We want to wrap that content. Because otherwise, it's going to take all available space. And we don't want it to take all available space. Wow, I put a lot of these things in here. That's a little overkill. Kind of regretting that now. I have to copy and paste 1,000 times. There we go. See now how they're showing up? See, that makes me feel better. There we go. So let's run it again now, though. Notice there was a huge pile of those, right? There. I didn't even count. How many did we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, maybe even more as they start to go off the screen. Okay, I'm only getting 1, 2, 3, 4, 5. Okay, the rest of them are here, but they're behind this other fragment. So sometimes we want things to be able to scroll up and down. That's really easily accomplished by wrapping this whole thing in a scroll view. Now, when we do that, we want to make sure, I want my linear layout still, but because this guy is now the root one, I need to move the namespace stuff up here to him. And let's cut this and put it down here at the bottom. There we go. Okay, and our scroll view, if you notice it's complaining because it doesn't know how big to make it. Well, let's make the scroll view take as much space as it can get, just like our linear layout did, by matching that parent. So now when our application runs, we can scroll within it. And you'll notice how as you click into each of these, if I have an amount spent, I spent 12. That amount spent stays there so the user remembers. You don't have to worry about all the fancy layouts, and it all animates for you. It's nice and cool and pretty. If you choose to use the edit text instead of one of these, it's the same behaviors, but you get the idea from there. Okay. Hopefully that all makes sense. If you have questions, as always, make sure to put those in the discussions. Otherwise, we'll see you guys online.